This is a Coulisse mechanism. It's a type of transmission that allows the transmission of rotational energy through an intermediary sliding block. This particular design is going to give us a 2-to-1 transmission ratio, and it consists of all 3D printed parts. Here is the final design. Again, everything here is 3D printed with the exception of the hot glue used to hold the shafts in place. You can see that this particular design has a dead point. It is a point in which the geometrical configuration forces the linkage to lose its mobility. So when I rotate the input shaft, you can see everything works fine, the slider moves along, but as it becomes collinear with the output shaft, you'll notice that the slider block retainer actually rotates freely, and if it gets out of position, the input shaft will bind. So to test this in a more practical example, there's no load, so I guess it's not that practical. Here's a drill running it at about 800 RPM, and you can see that it doesn't bind, and it continues to move through. But if we look at the slow speed footage, you can see the binding. And there it is. It's that little range of motion where we have a dead point. If the system was actually loaded, I would think that you probably have some issues more often than not where it would actually bind at that point. But spinning it freely like this, it still is able to move okay. So overall, is this a 3D printable design? Does this work? Well, yes, I think it does. Be very cautious of that dead point and consider what type of application you're going to be using this for, and it should work fine. I've been inspired to learn more about mechanical design by retired mechanical engineer and YouTuber Thang010146. His YouTube channel has over 3,000 mechanical animations that he created himself, and he's constantly creating new ones almost daily. I've been a fan for a while now, and I would like to challenge myself to recreate some of his designs and 3D print them to see how well they function out of a printer. He's a genius. You gotta check him out.